All right, conceptual geometry, unit 9, day 9. This theorem is very simple. We like to use this when we have a circle that's inscribed in a triangle. And it simply says if two tangents are drawn from the same external point, the lengths of them are congruent. Really simple. Those two pieces are congruent. This is actually my favorite problem of the unit. It deals with congruent pieces in a circle, and we just have to do some simple arithmetic. Here's what the diagrams are going to look like. Now, before we actually calculate the perimeter, I like to do this, because it looks a little bit more complicated when we put 3 of them on there. So let's mark our figure. Those two pieces have to be the same. Those two pieces have to be the same. And then these two pieces have to be the same. And then once you understand that, it becomes real simple. Well, if that's 2, that's 2. If that's 8, then that's 8. And if that's 3, then that's 3. Now, we should already know that to find the perimeter, you just add up all the sides. You can actually add up all the small sides if you want, but I like to do a little arithmetic ahead of time. It's simple to do. This length will be 5, 2 plus 3. This length here, 3 plus 8, will be 11. And then that side there is 2 plus 8, that's 10. So I just find it a little bit less writing to do it this way, but you don't have to. You can write out all the individual numbers if you want. So 5 plus 10 is 15 plus 11. The perimeter of that triangle is 26. All right, number 2, in the diagram, PQ, QR, RS, and SP are all tangents. Now, before I even look at what the lengths are, let's kind of do this again. Oh, those two pieces are equal. Those two are equal. Those two are equal. And then finally, those are equal. And it says PT is 8. Well, right away, if PT is 8, I'll highlight it. Then PW has to be 8. QR is 12. Well, that's interesting. QR is 12. That's going to make it a little bit more challenging. VR is 3. So let me use a different color here. VR is 3. So I know RU is going to be 3. And VS is 2. All right, so VS is 2, which means SW is 2. All right, so what's kind of cool about this one is we have to use these two numbers to find a missing length, because I don't know what QU is, and I don't know what QT is. I know they're the same, but notice here, if that whole side is 12, but just that piece is 3, if we do 12 minus 3, that gives us 9. So QU has to be 9, which means QT has to be 9. And then again, we want to find the perimeter. So this bottom side here is 5, 2 plus 3. That side there is 10. And the top side here is 17. And I know QR is already 12. So my perimeter, if I start over here with the 10, would be 10 plus 17 plus 12 plus 5. 12 plus 5 is 17. 17 and 17 is 34. Plus 10 is 44. So that's a little bit higher level question. You probably wouldn't see this on an exam, but it's good to do in notes and maybe a work session. Okay, our next example, it says AD is a diameter. AB is 24. And the radius of the circle is 5. So here's the key. The radius is 5. The radius is the distance from the center to the circle. So just that piece is 5. Which means that piece is 5. Which means the whole side is 10. Then it says find BD. So we've used this application a few times throughout the unit. You're like, well, it has actually Well, it's got a little to do with the circle, but we're really mainly concerned with this triangle here. The one thing it has to do with the circle is that AD is a diameter and BA is perpendicular to DA. That's a right angle because it's a tangent and a diameter. I want to find this missing side here. We just use Pythagorean theorem. 10 squared plus 24 squared equals x squared. 10 squared plus 24 squared is 676. And then the last step always in Pythagorean theorem, let's square root it. X is 26. All right, again, another theorem with tangents of a circle. It's kind of common sense. It says if two tangents are drawn from the same external point, the triangles formed by them, two radii, and a segment connecting the center form congruent right triangles. So the right angles are actually where the tangent and the radius meet. Those are right angles. That side's the same in both. Those two sides are congruent, and the radii are congruent. So it forms two congruent right triangles. All right, maybe I'll highlight these. So this yellow triangle here is congruent to that green triangle there. All right, not a ton of work to show for these. So example 4 says given circle O with tangents AC and CB. Well, those are two tangents drawn to the circle from the same point, so I know those are congruent. I know those radii are congruent, and I know both of these are right angles. It says if AC is 12 and the radius of the circle is 5, find OC. So we want to find this side here. I don't even really need two triangles. We just did one like this. It's Pythagorean theorem. The one part that I see missed a little bit in this is knowing where that right angle is. So 5 and 12 are the two legs. X here is the hypotenuse. So we'd set it up 5 squared plus 12 squared equals x squared. Then you put that into your calculator, you get 169 equals x squared. Then you square root it, and x is 13. Example 5 is similar, a little bit of a twist here. Again, it says given circle O, so it's the exact same diagram. Tangents AC and CB, find AC. So now I need to find this side. If OC is 17 and the radius of the circle is 8, we are again going to use Pythagorean theorem, but this time x is one of the legs. So we have something that looks like x squared plus 8 squared equals 17 squared. Now on the other side, when the two numbers are on the same side, you just add them. But now I need to subtract 8 squared from both sides. And again, don't even mess around with 17 squared, figuring out what that number is, 8 squared. You just take on your calculator and you type in 17 squared minus 8 squared. That gives you 225. Then you square root it, and x is 15. And our last example. Given circle O, tangents AC and CB. Again, find the diameter of the circle. Oh, that's new. If OC is 15, so there's this side, and AC is 12. Well, remember, there's the right angle. I can't find the diameter yet. I need to find a radius. So we're going to find x, which is the radius, not the diameter. Just remember at the end, you need to find that. But first, we need to find x. Okay, so I've got x squared plus 12 squared equals 15 squared. And then we're going to subtract 12 squared from both sides. That's going to give me x squared equals 81. Then we square root it, and x is 9. But don't circle that. That's not your answer. Remember, x represents the radius. To get a diameter, you need to multiply the radius times 2. So the answer to the question, the diameter, would be 18. And that concludes lesson 9.9.